Our fourth and final technique for evaluating limits algebraically is simplifying complex fractions. Now, whenever you are evaluating a limit, always begin by trying direct substitution first. If direct substitution gives you a real number, that is your solution. That still hasn't changed. If, however, direct substitution yields the indeterminate quotient, 0 divided by 0, this is a sign that we need to try another technique. And if we are dealing with complex fractions, that means fractions inside of other fractions, we want to simplify the complex fraction. For example, evaluate the following limit algebraically. We have the limit as x approaches 0 of 1 divided by x minus 8 plus 1/8 divided by x. Well, if we try our direct substitution, we end up with the indeterminate form 0 over 0. Now, there aren't any polynomials to factor, there are no square roots to rationalize, but we do have complex fractions. We have fractions inside of other fractions. So what we want to do is we want to simplify our complex fraction. There are two parts to this. One, we need to get a common denominator between our terms in our numerator here. All right, we want to combine this into a single fraction. So here we have two fractions connected by addition. We want to combine them, and if we're going to combine fractions, we have to get a common denominator. And we also want to rewrite this division as multiplication. Notice that dividing by x, well, that is the same thing as multiplying by 1 over x. So let's think about the common denominator. To get a common denominator, I'm going to have to multiply this first fraction by 8 over 8. Notice to get a common denominator, we multiply the numerator and denominator by the denominator of our other fraction. And we're going to multiply the second fraction by x minus 8 over x minus 8. And we are allowed to do these manipulations because each of these is the same as multiplying by 1. Then, again, remember, dividing by x, well, dividing by x, that is the same as multiplying by 1 over x. This leaves us with 8 over 8 times x minus 8. Notice we can just leave this in our factored form, plus x minus 8, that's what I get when I multiply x minus 8 times 1, divided by 8 times x minus 8. Notice our common denominator now, times 1 over x. So instead of dividing by x, we multiply by 1 over x. Now we can begin to simplify. Well, we have a common denominator. Once we have a common denominator between fractions, all we have to do is we add the numerators. We have 8 plus x minus 8. Well, 8 plus x minus 8, my 8's are going to go away, leaving me with just an x in the numerator. We have x divided by 8 times x minus 8 times 1 over x. And as hopefully you have seen here, we now have a factor of x in the numerator, a factor of x in the denominator, which we can then divide out. All right, so again, whenever you do these processes, you should end up with a common factor that is going to divide out to allow you to simplify. So we cancel out those x's, we simplify the limit. We now have the limit as x approaches 0 of 1 divided by 8 times x minus 8. We can now do our direct substitution. Plugging in 0 for x gives us 1 divided by 8 times 0 minus 8, which is negative 1 over 64. We can verify our answer graphically as well. Here's what the graph of this function looks like. Notice that there is a hole in the graph when x is equal to 0. Well, even as our x values approach 0, even though there is still a hole in the graph, the y values are getting closer and closer and closer to negative 1 over 64. Let's try another. The limit as x approaches negative 2 of 1/3 minus 1 over 1 minus x divided by 2 plus x. Again, we begin by trying direct substitution. Well, our direct substitution gives us the indeterminate quotient 0 divided by 0. We don't have any polynomials to factor, we don't have any square roots to rationalize, but we do have complex fractions that we can begin to simplify. So, Notice we can simplify our numerator here by combining these two fractions. They're connected by subtraction. Well, to combine two fractions by addition or subtraction, we must first get a common denominator. That means I need to multiply this first fraction by 1 minus x divided by 1 minus x. And I need to multiply this second fraction by 3 over 3. Notice we multiply the numerator and the denominator by the denominator of the other fraction. Similarly, we need to also divide by 2 plus x. To divide by 2 plus x, we can rewrite that as multiplication of 1 over 2 plus x. So, we now have 1 minus x, notice that's my new numerator of the first fraction, over our common denominator of 3 times 1 minus x, minus 3 over 3 times 1 minus x, times 1 over 2 plus x. We turn this division into multiplication. Dividing by 2 plus x is the same as multiplying by 1 over 2 plus x. Let's simplify what we have in the parentheses now. I have 1 minus x minus 3. Well, 1 minus 3 is going to give me a negative 2 minus x. We have negative 2 minus x divided by our common denominator times 1 over 2 plus x. Now, whenever we do this, we have to get something to cancel out. We recognize here that the numerator of our first fraction looks similar to the denominator of our second fraction. In fact, they are opposites of each other. So what can we do with the numerator here? We can factor out a negative 1. We factor out a negative 1 from the numerator. That gives me negative 1 times 2 plus x over 3 times 1 minus x times 1 over 2 plus x. And now we can clearly see our common factor that we can divide out. We can divide out this 2 plus x and simplify our limit. We are now left with the limit as x approaches negative 2 of negative 1 divided by 3 times 1 minus x. So I just brought that negative out in front of our fraction here. And now we can try our direct substitution again. Plugging in negative 2 for x, well, 1 minus a negative 2, that gives me a 3. 3 times 3 is 9. Negative 1/9 is going to be our final answer. Graphically, here we have the graph of 1/3 minus 1 over 1 minus x divided by 2 plus x. We have another hole in the graph at x equals negative 2, where we are evaluating our limit. However, we can see that as the x values get closer and closer to negative 2 from either side, the y values get closer and closer to negative 1/9. And one last example here. Evaluate the following limit algebraically. The limit as x approaches 3 of 1 over x squared minus 1/9 divided by x minus 3. Again, we try our direct substitution first, and direct substitution yields the indeterminate form 0 over 0. We have complex fractions, so let's simplify them. We will have to get a common denominator to combine our two fractions in the numerator by multiplying our first fraction by 9 over 9 and our second fraction by x squared divided by x squared. Also, we want to, instead of divide by x minus 3, multiply by 1 over x minus 3. Multiply by the reciprocal. This leaves us with 9 over 9x squared minus x squared divided by 9x squared. Notice now we have a common denominator times 1 over x minus 3. Now that we have this common denominator, we can begin to combine these two fractions. 9 minus x squared divided by 9x squared times 1 over x minus 3. Now, as I said before, we always have to have a common factor between our numerator and denominator. Well, it might not be completely obvious here, right? But one thing that we can recognize is that we have a difference of squares appearing here in the numerator. Well, let's go one step at a time. Let's begin by factoring out a negative 1. And if I factor out a negative 1 from my numerator, I have negative 1 times x squared minus 9. And now this x squared minus 9, we can factor that into x plus 3 times x minus 3. And now we can see our common factor of x minus 3 between the numerator and the denominator. And as you guessed, yep, divide them out, simplify the limit, And now we can retry our direct substitution. Plug in 3 for x. Plugging in 3 for x gives us negative 1 times 3 plus 3 divided by 9 times 3 squared. 3 plus 3 is 6, so I have negative 6 divided by 9 times 9, negative 6 over 81. Well, that reduces into negative 2 divided by 27. And don't be afraid to use the math frac feature of your calculator to help you in simplifying that fraction. Again, graphically, we can verify our result. Here I have the graph of the function. When x is equal to 3, we have a hole in the graph, but as my x values get closer and closer to 3 from both sides, our y values get closer and closer to negative 2 over 27. All right, and so that is your fourth and final technique for evaluating limits algebraically, simplifying complex fractions. Obtain a common denominator to rewrite the expression, and rewrite your division as multiplication. Right? Rewrite the division as multiplication. Get rid of those complex fractions. And in doing so, you will obtain common factors in the numerator and denominator that you can divide out and simplify your limit. Once you have simplified the limit, try again with direct substitution.